Assalamualaikum and salam UiTM di hatiku to our beloved lecturer, Madam Rozaimah Zainal Abidin, as our lecturer for code STA340, Design and Analysis of Experiment, and to all F4CS 1115B students. So, we are from F4CS 1115B will present our study, which is our study is the simple pendulum experiment. So, let me introduce our group members. First, Mohamad Azriel bin Azaian. Second, me, Muhammad Taufiq Hidayat bin Roslee. And lastly, Ezmier Ashraf bin Sallehuddin. So the first slide is the introduction of our study. So we are going to tell you about the law of simple pendulum. So as you can see, that is the formula for this law. T equal to 2 pi square root L over G, when L is the length of a simple pendulum and G is the acceleration due to gravity. So there is another 4 laws in this law. Law of mass, law of length, law of isochronism, and law of gravity. Law of mass stated that the time period of the simple pendulum is independent of the mass and material of the bob. This property is known as the law of mass. Second, law of length. The time period of the simple pendulum is directly proportional to the square root of its length. This property is known as the law of length. So, this is the law that we use for our experiment, where we use a different lengths of simple pendulum. Third law is law of isochronism. The time period of the simple pendulum is independent of the amplitude, provided the amplitude is sufficiently small. This property is known as the law of isochronism. The oscillation of the simple pendulum is isochronous. And last but not least, law of gravity. The time period of a simple pendulum is inversely proportional to square root of the acceleration due to gravity at that place. This property is known as the law of acceleration due to gravity. The problem statement for our study is how does the length of the simple pendulum affect its period of oscillation? We want to explore which length of pendulum give the longest time for 10 oscillations.
Okay, next, the objective of our study is to know the mean difference in time of 10 complete oscillation. In this experiment, we want to see how the length of a simple pendulum affects its period of oscillation. Next, experimental design. For choice of design, we choose completely randomized design (CRD) as our design experiment. CRD is being chosen since the experiment only has one factor, which is the length of the pendulum. And then, the number of replication in our study is 4.
The factor for our experiment are the lengths of a simple pendulum will complete 4 trials of 10 oscillations. The levels for our experiment are the 5 distinctive lengths of simple pendulum are chosen and being compared to observe whether the length of simple pendulum affects its period of oscillations. For response variable, first, let's see what response variable is. Response variable is a dependent variable, meaning a variable that depends on another variable. In our experiment, The response variable that we have identified is the mean difference in time of 10 complete oscillations.
We move to the next slide, materials and methods. So for the materials, we are using 300 gram wick, phone stopwatch, ruler and string. For the methods, number 1, obtain a 300 gram wick and a roll of string. Number 2, set the apparatus. Number 3, prepare a simple pendulum with a 0.3 meter long string, measure using a ruler. Accounting for the knots tied by the mesh and the nail, tie one end to the wick and another one to the nail. Make sure that the final recorded length accounts for the knot and any other lost string length. Number 4, draw a table to record the time taken for 10 oscillations. Number 5, pull the pendulum to one side, then release. At the same time, start the stopwatch. Number 6, record the time taken for 10 complete oscillations in a table. Last but not least, number 7, repeat step 2, 4, and 5 using a simple pendulum of another length, 0.6 meter, 0.9 meter, 1.2 meter, and 1.5 meter. We move to the data analysis. So this is the data that we gain in our experiment. Time for 10 oscillations for different length of pendulum. We repeat 4 times for each length. So we are going to analyze the data using ANOVA, the key test, Fisher's list significant difference test, and last but not least the next test. So before we start with the ANOVA, we are going to check the assumption of ANOVA. The shape of the distribution, the normality assumption, and the constant variance. So first assumption, the shape of the distribution, we are going to check using the histogram of average time taken for 10 oscillation. So from the histogram, we can see that the assumption of the error is satisfied since it is normal distribution. For the next assumption, the normality assumption, we are going to use the normal probability plot of average time taken for 10 oscillation. So from the graph, from the plot, we can see that normality assumption is met since points are plotting in a straight line center. And last but not least, the last assumption, homogeneity of variance, we are going to use scatter plots of residual against fitted value. So from the scatter plot, we can see no pattern shown and the residual scattered randomly around 0. So we can conclude that the error have constant variance.
Okay, for the first data analysis, we conduct analysis of variance ANOVA for the mean difference in time of 10 complete oscillation. Based on table 2 ANOVA, we already calculate the sum of square, degree of freedom, mean square, and F value. And after that, we conduct hypothesis testing for H null, mu1 equal to mu2 until mu5, and H1 at least one mu are not equal. And then for test statistic, we already calculate F value and get 7177.33. And for critical region, we use alpha 0.05 and use 4 and 15 and get F critical 3.06. For decision rule, reject H null if F value are greater than F critical. Since our F value 7177.33 is greater than F critical 3.06, we reject H null. And for the last one, for conclusion, at alpha 0.05, we can conclude that there is significant different mean of 10 complete oscillation. Okay, next one, we conduct Turkey HSD. Based on table 3 Turkey, we calculate the mean difference I minus j, standard error, significant, and 95% confident interval, lower bound and upper bound. After that, we conduct hypothesis testing for H0, mu I equal to mu j, and H1 mu I not equal to mu j. For test statistic alpha, we use 0.05 and get T critical 0.22. For decision rule, we reject H0 if mu I minus mu j are greater than T critical. Since all of the mu I minus mu j are greater than T critical, we reject H0. For the conclusion, we can conclude that all of the mu I are not equal to all of the mu j.
Fisher's least significant difference. This is our Fisher's least significant difference table. The hypothesis testing for Fisher least significant difference are H0 is mu I equal to mu j, and for H1 mu I not equal to mu j. For test statistic, the LSD value that we got is 0.1846. All value that we got in decision rule are greater than 0.1846. Finally, for the conclusion, we conclude that all pairs of means are significantly different and we managed to reject H0. For Dunnett's test, this is our Dunnett's test table. We choose the fifth variable as a control. Hypothesis testing for Dunnett's test. For H0, mu I equal to mu 5, and for H1, mu I not equal to mu 5. The value for test statistic is 0.2364. All the value in decision rule are greater than 0.2364. As a conclusion, we reject H0 and all pairs treatment means have a significant difference and all mu1 to mu4 are not equal to mu5.
For the last one, the conclusion, based on the experiment, we can conclude that the length of the simple pendulum of 1.5 meter has the highest time taken for 10 oscillation among others lengths. The longer length of simple pendulum, the highest time taken for oscillation. As our recommendation, for the further study, we as a designer of experiment can use many other alternatives like the different type of string or different way to be used for being compared.
Thank you for watching our video presentation. Don't forget to drop a like and subscribe to the channel.